everyone. Welcome to the Engineering Theatre at Rail Live 2024. It's an absolute pleasure to have you along. First of all, I want to say thank you very much to Pandrel for sponsoring this theatre and supporting with events. They were speaking yesterday, making me very excited because they were talking about undersleeper pads. You can catch up with all the previous videos from yesterday and everything that goes out today online on the Rail Live website. I am absolutely delighted to have Kate Luff here from One Big Circle. We're going to be talking about all things. Well, this is the AI session, which has somewhat started to feel ubiquitous these days. But actually, no, it's not the AI session. It's the machine learning session. We're going to be talking about a very specific tool and all about it. But first, Kate, tell us about One Big Circle, because One Big Circle has quite quickly become a fairly ubiquitous tool for, I'm a design consultant, but lots of my colleagues in all sorts of parts of the rail industry are using the tools that One Big Circle have created. So tell us about One Big Circle and tell us what those tools are.
Okay, so hi everyone, I'm Kate. I've been at One Big Circle about 1.5 years, but background before was working for a tier 1 contractor in the rail industry, so sort of on the sharp end out doing track renewals. And obviously, I think Emma spoke about all the challenges around that in the session beforehand, so actually this works quite well. It's a bit of a follow-on. But what One Big Circle do, and have done really well, is find a bit of a niche and a gap in the market, which is making data accessible. So taking that forward-facing video data initially from a cab, so effectively a virtual cab ride, capturing it automatically, transmitting it automatically up into the cloud and providing a really easy interface to go and access it. And then that availability, it's not just Network Rail that use it. We've got data sharing agreements in place, which means that any supply chain user, as long as you're working on a Network Rail project, you can go and access that data as well. And that was just so powerful. Yep. Combine that then with the COVID pandemic, which then restricted sort of anybody doing cab rides, and it was essential works only on the railway to keep the railway moving for key workers, and then tie that in with all the health and safety updates and the ban on red zone working. There's been this real need and drive to make data available remotely for people to review. And why travel to site when you can go and look at that.
A lot of those pieces fell into place at a good moment.
Yeah, absolutely. And then I think the key has been working with the end users, so working with the Network Rail engineers on the sharp end, understanding what their challenges are and listening, and then sort of prioritising what do we develop next in Ava and the tools. So it's really simple things like working with the safety task force, and they asked for an overlay so that you can see the safe distance from the CES and whether or not you've got a walking route and things like that. So it measures from the track gauge, overlays onto the image, and quite quickly you can see, right, can someone actually walk from the access point, but we've imported that data in, to your site of work, which you've marked up, no, we've got a tree in the way, or we've got a structure or an object. And so it's quite easy for them to see that, whereas actually what would have happened before is you'd have gone to site, tried to do your shift, and then, oh, we can't even get to it.
So. Yeah, you can't even do the site recce because it's,
exactly. And then as we've started capturing more data, so branched out from visible data into IR, UV, the high definition line scanning imagery, so that's the black and white sort of imagery that you get, really detailed images of the track, and that could be up to sort of 7 cameras that we're then kind of tying together. So being able to see all of that is a huge amount of data that no one can review, at all. And that's where the sort of, as we say, machine learning then comes into it.
So that's exactly what I want to talk. So kind of the reason I wanted to have this session is because AI is a bit of a tech industry buzzword at the moment. It means all sorts of things. Most of the people trying to pitch AI are grifters and should not be trusted. However, within our industry, there are a lot of very, very useful applications. So forget AI as a term. If you hear AI, ask them what it is. No, not AI. What do you mean? What's the technology you're actually talking about? It's a really important question to ask people. What we're talking about is machine learning, specifically here. Machine learning we've been using in the railway for quite a bit of time. Network Rail have used it for PLPR for quite a number of years. So machine learning, well, I'll let you say what machine learning is in a second. But machine learning is often within the umbrella of AI. It's a very, very specific application of, and it's related to mass data, right? So as we've collected more and more information on our rail, as we attach more and more sensors to things, it becomes impossible for us to use the previous techniques to look at that data. And also, it's to unlock that data, we need to analyze it. And again, a human cannot analyze that data. So this is where machine learning comes in. So I wanted to, first of all, give us a little bit of a description of what machine learning is, and then maybe talk about where it is and isn't applicable. So where it is good and is useful, and where maybe it's not the right solution.
Yeah. Okay, so I'll start with our kind of general approach that we take. So quite often if someone comes to us and sort of, here's a problem, here's a challenge, and they'll describe it to us, and the kind of feedback that we get is, well, if you can see it with the human eye, then we can teach the machine to do the same thing. One of our recent ones is troughing. So obviously you can identify troughing in a video image, but you don't want to sit there and watch hours and hours of video footage. So you want the machine to be able to tell you, where's the troughing? And once you can do that, so we sit there and we mark up loads of images of troughing, and we make sure that we work with the end users to understand, like we've got the experts in Network Rail, so we want to know exactly, okay, what do you want to know about the troughing? Yep. So then you go and start to classify it. Okay, is it concrete? Is it composite? Is it raised? And whatever they want to know from that. And then it's kind of, okay, now we want to know, is there a problem with it? So have we got missing lids, cables over it, vegetation, is it obscured? So it's really working with the end users, and all of that information that we do, we mark up and we do basically a training set.
I was going to say, training is that key word, isn't it? It's really important for machine.
Exactly. And then we'll run that. We'll review the results, again, with the end users. And if there's things that, may have been missed or may not have been, we can then refine that, and it can become iterative. And we always call it human in the loop. So it's really important that any of the machine learning that we do, actually all we're doing is trying to identify a needle in the haystack for you. There's so much data out there. There's millions and millions of, let's use that analogy, like haystack needles there. So how is anyone ever going to know? And what we can do is actually reduce it maybe down to 100, and then the engineers, we've got some priority, we've got somewhere to look.
If you like, that then,
And it's never going to be 100%, but neither's a human walking along a track. They're going to miss things as well. So actually it's let's use all this different types of machine learning, and actually what we see now as maybe the way forwards is using multiple different sets of machine learning, because no one set is going to get it right. So do you combine multiple different sets of machine learning, using the same data, all written slightly differently with different algorithms, sort of backing them up. And actually that gives the sort of end user or engineer a much higher level of confidence, because actually I've got 4 sets of machine learning models that are telling me this is now a problem.
So training is, so for these models that basically take a huge amount of data, in this case and in lots of other cases, it's visual data, which is kind of quite good, because it's often quite repetitive. There are lots of common things, shapes that the algorithm picks up. Getting that training data, first there are a few things, I suppose. The scale of training data, you have to have a sufficient scale of training data for the things. So a good bad example, if you like, is where machine learning was used on a data set, including X-rays for picking up tumors, and it was getting 100% hit rate on this data, and they realized that it wasn't because it was picking up the tumor, it's because the X-rays for the tumors all had the hospital name in the top corner of the X-ray scan, and the machine was picking up the hospital, which was different for the positive pickups versus all the others. So that's an example, a bit of a crude example, but it gives where training data is really important, right? So talk a little bit about how you validate that, how you make sure you've got the right training data.
Yeah, so as you just said, there's kind of 2 measures that we use. It's precision and recall, which is basically, do you want it to pick up absolutely every positive thing that you see? Well, that's great, but you're going to get so many that you don't know what to do with it. Or do you sort of say that it has to be like really, really accurate and everything else? So it's finding that balance on the curve of not being overwhelmed with the data, but having good quality data. And as I said before, like you're never going to be 100%. So that's why if you sort of put multiple machine learning algorithms together, you've got much higher confidence that you're going to get it right.
Yep. So, in terms of collecting that, what did the process look like in terms of, you started by saying, well, we've got this cab imagery, let's start playing with it. What did that actually look like in terms of the story of, we're going to pick up, in fact, I suppose it's a bit of the origins of One Big Circle, actually, is where did you start getting that data source from? Was it Network Rail's cab data, and then because you have to build up a certain volume of that data. So what did that story look like of going, right, we need to start collecting this data? What was kind of a little bit about that story?
I think One Big Circle is a little bit unique here because it's like an end-to-end product system. So we've got all the hardware capability. So cameras on trains isn't a new thing. but actually being able to tap into the forward-facing CCTV on a train is almost impossible. I would say so. In a lot of cases, we end up having to put another device on the train, or the existing CCTV might not be sufficient quality for what you want to do. So we've got a number of hardware solutions where it might be a temporary camera, which means you can move it between different trains. Obviously, the advantage of that.
And is that service trains? So is that with some train operators, or is it all Network Rail trains, or?
No, complete mix. We work quite closely with a lot of train operating companies and freight as well.
Okay, yep.
Quite importantly, and we've made use of the fact you've got a tail lamp bracket on pretty much most classes of vehicles in the UK. So Network Rail designed a yellow box, really great. You can put it on any train that's got a tail lamp bracket, and inside that yellow box we can put anything. So we can put visible, thermal, multiple visible cameras to get the angle of whatever the user wants to do, and that can move between trains. And then for some of the more permanent installs, so if you want to do that on in-service passenger trains, which is kind of, I think, where the move's going to. So we go to in-service passenger trains, you think that's great because you can get the reliability and the repeatability of the data, but I think one thing you've then got to be aware of is, okay, do you actually need all of that? So that's when you start moving, do we need to do things on the edge and sort of choose which bits of data go up?
So some of my first experience of machine learning applied on the rail, I've already alluded to it, was with Network Rail. Actually, their plain line pattern recognition technologies. They collect per shift 9 terabytes. That's 2 shifts a day. So that's the best part of 20 terabytes, which is more data than any of us will generate individually without no matter how much you snap away on your phone. Huge amounts of data per day getting collected up. I imagine the scale is, okay, so they're collecting very high resolution imagery all year round. So the scale is slightly different, but you're still collecting a lot of data. What happens to that data? And do you server store it, or is it, what's happening to that data? And partly because one side of the equation is the machine learning. The other side is people being able to access it, and there have been solutions to access cam video in the past, but the challenge was always that it was really difficult to get access. Whether it was BR and it was a load of VHS tapes on a shelf, or whether it was a portal that required 3 different passwords, it's always been a bit clunky. One of the differences with One Big Circle's tool with Ava is that it's much easier to access for everyone, not just Network Rail. I suppose partly the question is, how do you ensure that interface, as you put more tools in, how do you make sure that interface remains easily accessible? And also, how do you manage that quantum of data? Because as you say, the data is getting more, as you go round and round, you're collecting more and more data. So a little bit about data, but also keeping the accessibility to the data. Those two.
So I think for the data, it comes back to sort of dynamic demand. We're getting a lot more equipment out onto the trains, and actually, do you need all of it? So if we take an example of a train that runs, goes backwards and forwards on a route for the whole day, okay, I'm not sure I need to see that same bit of track, but actually there might be an incident, in which case that is important. So the sort of concept that we've worked on at the moment is being able to kind of, on the edge, so on the train, you're recording, but what do you transmit? Because that's the expensive bit, transmitting the data, and actually giving ourselves a bit of a buffer. So if there was an incident, we can go and call off a certain section of data, because that's really important, and it can be kind of locked down and shared with the BTP or whoever needs to see that data. But actually, we can sort of set boundaries and parameters. So maybe we just want to have once a week a really good high quality set of data on this route, and we can tailor that a little bit to the needs and wants of whatever the route is. Obviously a branch line might have different requirements to the main line and that kind of thing.
And the other is about the interface. As you add, and we'll talk a little bit more about the developments in the pipeline and some of the fairly new tools, but as you add more tools in, how are you ensuring that, and there's more data, how are you ensuring that it remains easy to access and use, and that the interface isn't too clunky? How are you managing kind of ensuring it's easy to access?
So if anyone hasn't seen the Ava platform, it's basically YouTube meets Google Maps, and that's what it looks like. So as we're starting to do a lot more of the machine learning and you're getting the alerts, we've kind of realised that actually maybe you're not going to sit and watch the traditional sort of YouTube. So work in progress in the background, we've already kind of realised that this is going to be a challenge. And so we're developing a sort of platform that actually, when you land, it's going to be like a dashboard. So you can then choose, I'm interested in track, for example, and tick the various things that you want to see as you land. So I want to see that what my joints are looking like. I want to see track geometry alerts or any alerts that are all around the track, wet beds and things like that. So that's the aim of this sort of new dashboard. And as you say, and then there can be a link out, link, go and watch the video if you need to see the contextual view of where that came from.
Yeah, okay.
But just changing that navigation so people get to choose, customize, see what they want to see.
Yep. So we've alluded to it a little bit, but what are some of the developments that you've rolled out recently, and how are those being received, and what are some of the things that are in the pipeline of development?
So I think the good one to talk about probably now is signals.
Yeah, okay.
So quite often people navigate around in the railway by their signal ID. Sort of at the moment within AVA, you would have to go and search by the mile and yardage of your signal. So what we're doing is obviously we can detect signals. So the next development from that was actually let's character read the signal ID plate.
Yeah.
So we can now read the ID plate, and now we're locating them. So every time we pass the same signal, and most of them we've seen well over 100 times, we can now quite accurately say, we know this signal's here, it's in this location, and we can map it then as an asset, and then the user will be able to go in, search by your signal ID, you'll be able to see it with a level of confidence of this is the signal, it's been detected by AVA, sort of 90% confidence,
Yep.
and then if a human has then verified it, you can then see that it's got like the blue tick or whatever, you'll have the green tick to say,
Verified signal.
human verified, that we definitely know that that's there. So that's the new one coming, and that sort of applies to everything. So it's not just detections as sort of like detect the asset, but condition assessing and how can we make that useful and sort of tailor that information.
Yep. So we've got these. So we've got the ability to scoop in all this high resolution imagery. You've got the ability then to, in communicating, and we had a session yesterday talking about how you actually go out and speak to people and understand what the challenges are and how to kind of develop those products with Pandrel. So basically understanding what the problem statements are from your various potential user base. You get those, you then train, you've got all that data, you train the algorithm, if you like, the big algorithm off that data. There is one step that I wanted to maybe talk a little bit about, which is, and you've touched on it already, which is some of the human in the loop stuff, but validating that. So it's all very well having the training data, but how do you ensure that you've got a certain level of confidence? I wanted to talk a little bit more about that, because if people are going to pull lessons from that in other products and interrogating the quality of other potential machine learning products, that validation or that verification is very important. So I wanted to talk a little bit more about that.
You can do it a couple of ways. Well, one of the ways we've done recently is we call it a blind test. So we literally test a human against the AI to see how good it is. So we've done it for troughing and wet beds, and basically sort of the AI's run on a set of sessions, and then we've gone and asked some sort of the experts from Network Rail that we've been working with to basically, okay, you do the same. Yeah. And obviously, short section of track, we don't want to waste hours of their time, and just kind of see, like, have we picked up the same kind of stuff that they would? And that's a really good measure for us of actually, and in a few cases, we've picked up more with the AI than the human has, which is quite interesting.
Yeah, absolutely. So that's key. So you've got the training data, you validate, you verify, you ensure that it continues to be useful and that it's going to the right people. I suppose the last thing is really, where do you see this? So you've talked about what's in the development pipeline, but where do you potentially see this going? Focusing on what One Big Circle do, but also maybe a little bit broader in terms of how you see machine learning more broadly in the rail industry, and some of the other interesting applications you've perhaps seen that you think might kind of expand.
Yeah, so I think we're not alone in the machine learning space within the rail industry, especially, and we know that, and we think that's a good thing. Yep. So our kind of mantra is collect the data once, but that data can be used for so many different things, so many different use cases, and use cases that we don't even know about yet. And so actually make that data available, let everybody kind of come up with machine learning algorithms on it, and like we're saying, is actually combine that data, combine those insights that you get from that, and then you've got a much more sort of confident picture or accurate picture of the problems that you've got out there. So that's where we see it going, is a lot more sort of collaboration between different companies building the machine learning models and then sharing. So it almost doesn't matter which platform you log in to see that information. Whether it's a widget into a Network Rail sort of based platform, and actually you've got feeding in all the different insights. It doesn't matter what company name's on it, really, to be honest. It's about doing providing the right information and the accurate information to the end user.
Okay, thanks so much. I want to open it to the floor for questions now. So if you have questions, please raise your hand. Hopefully, well, for me, certainly, some very interesting bits and pieces to pick out of that. We have a question at the front. Thanks, Lisa.
Hi there, I'm Jill from Affinity. We're a business change consultancy, and everything that you've been saying today is super interesting, really, really interesting. I wondered about adoption challenges. So when people think about machine learning and AI, sometimes they run a mile because they're a bit scared of, well, is this going to replace my job? Is this going to replace me? So how are you managing to overcome those challenges, and have you faced adoption challenges?
So I think it's key that we work with the end users. So obviously we know the world that we live in now, budgets are tight, time is tight, resources tight. So actually understanding their challenges, and quite a lot of people sort of on the front line they just want some help of, I've got all of this to do and I don't know where to start. So actually the machine learning that we do, we're not replacing anyone, we're just trying to help them kind of prioritize the tasks that they want to do. So if you've got you know that you've got problems with joints, but on the section of track, we don't know which ones are the problems. Well, actually, use machine learning either from Ava or wherever else, and then have your priority list. Actually, I've got 10 that are really sort of urgent priorities that I need to go and look at. Well, that's way better than kind of sitting there going, oh my God, I've got miles to inspect and I don't even know where to start. So that's kind of where we've come from, really understanding those sort of challenges from the end user and trying to help them.
There's so track maintenance engineers are the people who are the ones who have a trace going, there's a bump there, please go and fix it. Or they get a phone call, even worse, from someone high up in the rail industry going, I just spilt all my coffee and it's your bit of track. So the ability to quickly go in and access access the data sort of portal and see and basically virtually travel that bit of track and say, can I spot anything? And even then with the machine learning, you don't even need to do the YouTube bit. They can just say what's within that section that's been flagged is very powerful to then understand how to redirect resources. So a point that I often make is that technology like this is not about, and we should not, much as some people might suggest that modernization is about reducing headcount, it should not be seen that way. We have a very limited pool of skilled people that we have access to as a rail industry, and what it's about is deploying those people and redeploying those people so that we do more railway stuff, so that we carry more people and things around. That's the key. We're always on the back foot with maintaining the railway. We are always desperate for more people. The reality is that we could have a blank check tomorrow. People would be the limitation on our ability to deliver. So giving people the tools to do more with the hours they have is absolutely critical. And to be honest, that's a key part of why this is happening.
And we've got a lot of knowledge leaving the industry as people sort of retire. So actually some of the machine learning, it's not just a question of like sort of analyze the data. You've always got to have that context and years of experience. And we've been on a number of calls with sort of experts in the rail industry, and they can sort of look at some imagery of a track and within about 10 seconds tell you exactly what the problem is. And like, we can't do that.
Get that knowledge out of their head.
That's literally what we're trying to do, is just sort of pull that knowledge out of their heads, help to put it into an algorithm, but at the end of the day, you've always got to present it back to the engineer for them to kind of look and understand the context, right, of that environment. Oh, we've got a failing piece of track here, but we know because we've just had this or we've had that or there's been a flood. So it's that context from the human side.
Absolutely. Good question. Any other questions? Any thoughts? Yeah, go on, Marcus. There.
Hi, Marcus Milton from the Rail Accident Investigation Branch. I have to say, I do use Ava, and it is fantastically useful, so thank you. I'm mostly just looking for a bit of reassurance that the raw footage will always be available, because often, for me at least, and I'm aware I'm a very small user of it in comparison to the industry, but it's the raw footage really for me that's usually the most useful bit of it. Will that always be available going forward with all your sort of machine learning stuff?
Yeah, and we'll always have the traditional platform, as I said, with the sort of the YouTube meets Google Maps, and we'll always continue to kind of improve that, the functionality and the tools. Obviously, you can measure and take annotations, but if anyone we get suggestions and feedback from users all the time, so we can always add things into that. And then what we're doing is for the sort of, anyone that does want to use that machine learning is creating that dashboard, as I said, that will be really, really easy to access and sort of get to your kind of issues sort of first.
Yeah, I was going to say, likewise, like, the other tools are very useful, but often I will fall back on, like, scrolling through and finding that, but just so I can look at that thing and go, oh, that's what that is, or, yeah, that looks all right. And so it's funny how much that, the traditional tool still is very, very
And
valuable.
how beautiful the UK rail network is. Oh my God, the imagery that we get from Wales and Scotland is just absolutely stunning. So if you've got a spare half an hour, I'd recommend.
To the team who do the helicopter footage from the and yeah, the various bits of footage from there, particularly when you've got a nice low sun and everything's nice and beautiful and it's all the autumnal colours. Oh,
Goes alongside the lochs in
I
Scotland.
know, you just have to put it. You just have it running in the background, and you with your cup of tea, and just sort of have it. No, I'm working away. It is, yeah, absolutely, yeah. These. Yeah, exactly. It's freeing up my time so that I can sit, rest, have a biscuit. That's it. No, yeah. Thanks very much indeed, Marcus. So, yeah, not that niche, but very valuable use of the information. Any other questions? Oh, a few here. So at the front here. Thank you.
Hello.
Hi.
I'm Shaina, Capital Delivery Eastern Region. So my question is, yes, we use your tool very much, especially around engineers meetings to understand the entire picture from a systems perspective, yes. So one thing we always stop is, yeah, we have every information we need so far. Do you collect any information underground?
Sorry?
The underground information.
Underground, so like ground penetrating radar.
Yes.
Unfortunately, not at the moment. We don't do ground penetrating radar, but not to say we won't in the future.
And in a way, again, everything would apply. Everything you've said would apply. Okay, you don't have the eyeball in the loop quite in the same way, but if you were to start getting a ground penetrating radar feed, machine learning would apply to that. It would, it's something that again you'd have to train. You have to have the right amount of data, but it is, it's something that would be possible to fit into that. Whether it was yourselves or someone else, it absolutely would be something that could.
And absolutely, we've got like a really agnostic approach to where the data's come from, whether it's our sensors or someone else's sensors, and kind of sharing that. We're having lots of conversations with other sort of technical partners of actually, you've got this data, we've got that data. Like, let's link it, because actually, the benefit is being able to overlap those different data sources. So whilst we don't personally connect it.
There's another question here. Yeah, thank you.
Hello, Andy Elms, data analyst from Network Rail. I'm using your signal locating thing quite a lot at the moment. One issue is, because it's a forward-facing video, the camera's at a different location to the signal itself. What kind of accuracy are you aiming for assets, for the actual geolocation of the asset?
Oh, tough question. So depending on the type of device that's on the train, will depend on the accuracy. So for some of the temporary devices, we're using the traditional GPS sort of positioning, so plus or minus a couple of meters. But for some of the more fixed permanent installs, we can make use of other sort of positioning systems that are on the train, so we get a much more accurate position. So this is actually a piece of work that we are doing at the moment to understand. But we've got to go through and kind of work out for each device, you've got a different level of accuracy. So you've kind of got to understand, like, actually, how does that then tie on if I've seen it 100 times, some with this level of accuracy, some with that level of accuracy. So yeah, apologies, don't have the answer quite yet, but it is a work in progress, yeah. Yeah. I'll let Sam know.
Mine's a slightly weird question, which is, how much of it do you actually understand what's going on? So I do structures, and to a certain extent you can look at steel or concrete and you can work out what the defects are and what might happen, and it can be relatively intuitive, and similarly with track. But when it comes to machine learning and coding and things like that, do you know much about coding, or is it just a really niche couple of people within the company who do know and understand what's going on? And are the dangers associated to that?
So we've basically got a tech background from the company side, and I'd say probably like 50% working in the kind of machine learning, software development sort of side of the company. And yes, very, very experienced coders, very bright, like sort of, well, market leading really, I'd say, but maybe I'm a bit biased. So yeah, a huge understanding. And then we've got myself, I came from a rail background, and there's a few others in the team that did. But actually, like I say, we work quite closely with the end users and understand their kind of challenges and trying not to make too many sort of assumptions. We don't have that 20, 30 years worth of rail experience knowledge that a lot of people in the industry do. So we're making use of the experts to get their sort of understanding.
Yeah.
Oh yeah, sorry. Wrong in sort of what sense?
I think what you're driving at is the validation process is I suppose what you're referring to, because the actual machine learning process can be a bit of a black box because it kind of grows itself a little bit of like what it's spotting. But it's that validation process that's key, isn't it? That human in the loop validation process.
And I think with all of the sort of new machine learning use cases that we do, we don't sort of like take some requirements at the start, disappear for 3 months, and then come back with, oh, by the way, we've done it, here you go. It's like we have weekly meetings, like bi-weekly meetings. So we're kind of, every time we get a little bit of a sort of update, okay, what does this look like? And we're reviewing it the whole time. So it's a very iterative process with the end users. So actually we get to the end and we've got something that's useful, rather than kind of, yeah, as I said, going away 3 months later and they kind of, that's not what we wanted. So it's keeping that conversation going as you work through each of those machine learning use cases and develop something.
Kate, thank you so much. That's been a really interesting and pretty wide-ranging discussion. Yeah, thanks everyone, particularly for questions. Thank you, of course, to Pandrel as well for supporting the theatre. We will see you all for the next session, which is imminently. But Kate, please give your thanks to Kate. That was superb. Thank you.
Thank you.